In this training, you'll learn how to implement an elementary inspection system powered by AI Vision. Let's walk through the process. Step 1 is to identify your inspection requirements, whether it's defect rejection or enabling traceability. We also want to verify the technical feasibility of the application by understanding the line speed, product and defect sizes, material type, and environmental constraints through a lab study or proof of concept. Once the application is validated, we move on to step 2, installing the inspection system on the factory floor. The key tasks in this step are first to schedule the installation while the line is down so that products can be manually fed through the station to capture and test images. Second, you must coordinate with your IT department well in advance to ensure that their security practices allow the elementary system to connect with the necessary cloud services. Elementary is SOC 2 Type 2 certified, and it's a trusted service used by many manufacturers globally. Once the installation is complete and an internet connection is established, turning on the system should bring you to a login screen on the HMI. Use the login credentials provided via email to access the system. Upon logging in, you may already have a station created in your organization. If not, simply click the Add button and create one with an appropriate name. Next, create a new product with an appropriate name. And finally, add an inspection recipe to your new station, selecting the product you just created within the dropdown. Now you're ready to tune your camera settings for optimal image capture. Adjust exposure settings and trigger timing to get images that maximize contrast between the feature of interest and the background. The lights spec'd for your system should provide enough light to use a fast exposure and provide a crisp image free from motion blur. Once image settings are dialed in, save the reference image that will be used to configure tools in the next step. In step 3, we select the inspection tool. It's important to select the correct tool for your inspection, and this will most likely have been decided when validating your application in step 1. Tools such as the barcode and text tools require no training, enabling you to read and verify text or barcodes immediately. Users simply configure the AOI on the reference image. The detect, classify, anomaly, and graded anomaly tools require training an AI model with a dataset that the user must label. The detect tool is used for determining the presence of a product or component in an image. The classify tool is used to distinguish between several different types or variations of product for binning or sorting purposes. The anomaly tool goes further to find small defects in products, and the graded anomaly tool allows users to discriminate between major and minor defects, with the option to either pass or fail the minor defects, depending on the type of product being manufactured and their scrap costs. You can refer to our product documentation found on the support website for in-depth information on each of the tools available to you. For the purposes of this training, we will be using an anomaly tool. Furthermore, you can train several defect types to better understand what quality issues are occurring in your factory. Configuring the tool is simple. Just resize the AOI on the reference image to fully contain the product while avoiding background that may negatively impact inspection results. When you are satisfied with your AOI, deploy the recipe and begin collecting images. In step 4, we begin capturing images of good and bad parts. Once you have a sufficient number of images captured, this can be 50 to 100 depending on your application, you are ready to navigate to the labeling gallery and begin assigning labels. You may use the buttons on the right-hand side of the window to label each image, or use the number keys on your keyboard. Additionally, you can hold the Shift key to label many images at once. This is especially useful if you have fed the inspection system known good and bad parts and can label all your images at once. If you're working to label many thousands of images or more, the Smart Group feature will be especially useful. By quickly clustering similar images, you can illuminate more diverse sets of images to label and ensure your model is robust. The progress bar on the left-hand side of the window indicates whether you have enough images for each label. When enough images are labeled, exit the labeling gallery and click the Train button. This process may take upwards of an hour. When complete, view the training report to view the accuracy of your model and identify images that were incorrectly identified by the model. You should look to add more examples of these types of images to reinforce the dataset. When you have added more data and feel confident, initiate another training, and when complete, review the training report again. Repeat as necessary until a satisfactory model accuracy is achieved. With relevant image data, this process should take no more than a few iterations. There's a label in the gallery called Test Set. Images labeled as Test Set will be used to validate the model but will not be used to train it. This ensures that the model is not overfitted to the training data and is actually useful in the real world. Be sure to deploy your final recipe before the next step. Next, in step 5, navigate to the inspection screen to begin running inspections. Click the Start Batch button and select your latest recipe. Your anomaly tool is now fully functioning and will reliably find defects in your production. If something changes on your line, such as a product change or a new defect type appearing, simply capture images of the new feature, label appropriately, and deploy the next model to production. Operators on the line can escalate new and interesting defects easily with the Share button while viewing the defects located here. The last step in setting up your elementary inspection system is to configure your quality events. There are often production issues that require immediate line stoppage due to machine or material failures. Sometimes these critical incidences are obvious and sometimes they are not. Quality events identify when critical incidences are happening and alert users via email or SMS messaging. The trigger for these events can be tied to defects detected in a row, over a certain number of items, or within a time period, or a rise in the defect rate over a period of time. You can also specify these events for specific item predictions or defect types. For example, if you know you have a printer upstream that is prone to failure, you may want to configure a quality event specifically for the text tool failure rate. Once your quality event is configured, navigate to the Notify tab and subscribe to the specific station, inputting the contact information appropriately. In summary, we've walked through the 6 steps of deploying a production-ready AI inspection model using Elementary. Step 1, application identification. Step 2, station installation. Step 3, tool configuration. Step 4, data labeling and training. Step 5, running live inspections. And Step 6, configuring quality events. When configuring your next inspection, know that models can be reused if the product is similar to its predecessor, eliminating the need to start from scratch and decreasing the time to deploy a working AI inspection model.